Welcome back. We're going to continue with our ions, and now we're going to begin naming and writing those ionic compounds. And so this is going to be a step for all of our naming and writing throughout the semester and as we're going forward to kind of help us out. And that first step is just kind of a general tip, and what it's going to do is we're going to look at drawing a line in our formulas. And what we're going to do is we're going to draw a line after the first element or word, depending on if we're naming or writing. And the one exception we have is ammonium, one of our ions we'll be looking at coming up. Ammonium is NH4, 1 nitrogen, 4 hydrogens with a +1 overall charge. It sticks together as one group. It's our only positive polyatomic ion that we have coming up, so we're going to see that a bunch. So as we're going, that'll be just a little bit different. We're going to split it afterwards. So to draw our line, if we have sodium chloride as an example, we're going to draw a line after our first element or first word. So we're going to separate sodium from our chloride. NH4, ClO4. We said we're going to draw a line after the first element unless we see NH4. Then we're going to draw it after the NH4 to separate our two parts from one another. So that'll be our first tip to help us out, is going to be to draw a line. Now our ionic compounds are going to be made from a metal, the positive, and a non-metal negative. The one exception we have is ammonium. Ammonium is a positive NH4 with a plus charge to it. So it's going to be our one exception. Instead of a metal, it'll be a polyatomic that's a positive charge, and we'll get into that as we're going. So just have to know that exception now. At the bottom of your page, we need to do a little bit of small writing there on the bottom of number 11 on the left-hand side. So to begin with, we have a couple steps we're going to follow. First off, our notes that we need, going to write small, is the first one. We're going to draw a line in our compound. If it's a metal and a non-metal, we know it's an ionic compound and we can continue with these rules. The line separates the cation from the anion. From there, we're going to write the symbol and the charge for each ion. Remember, we can use your gold packet and periodic table to tell us those charges. Remember from just before, Roman numerals equal the charge. So if we have a Roman numeral, that's how much positive charge. Remember, it's always positive if we have a Roman numeral. And then we're going to crisscross and simplify if we need to. Cation is always written first. The anion is always written second. So, example, lithium oxide. Draw a line between the first element or name and the second one. Second step, write the charge for each ion. Lithium is a plus charge. It's in group 1 on the periodic table. Oxygen, oxide. The oxygen ion ends in IDE, so we know it's an ion, it's a -2. So our positive first, negative second. Now we're going to write the charges. Now we're going to crisscross and simplify. So we'll think about lithium having a 1 there. Don't need to write it, but the 1 moves down to how many oxygens we're going to have, and the 2 moves down to how many lithiums we're going to have. Don't write the charges. So in the end we have Li2O. Don't write the 1s. Remember, these numbers are written as subscripts, written down below. That tells us how many element. Don't write the charges, just the number. So that's always going to work out. Lithium, we need 2 positives and 1 -2 to keep us neutral or balanced out. So that's how it's always going to be able to work. If we need to, we'll simplify. So if we have 2 of the same number, we'll reduce it down, would be an example there. So to try a few of these out. So if we were to look, we draw a line between our two, silver and fluoride. So silver Ag, if you look on your gold packet or your periodic table, Silver only has one charge, it's always a +1. Fluoride, group 17, is going to be a negative charge. So when we crisscross those two ones, we end up with the formula AgF. Don't write 1, so not AG1F1. No. Alright, for 2, iron 2 oxide. What we know about the iron 2 here is that means that iron is a +2 charge, oxygen is a -2 charge, so when we crisscross, we end up with FeO. Why we got this formula? We said we could simplify. There we go, simplify. Instead of Fe2O2, we're going to simplify it to be FeO. Copper 1 sulfide. Copper is a +1 charge in this case. Sulfide sulfur, -2 from our periodic table. So when we crisscross, it's going to tell us we need 2 coppers and 1 sulfur, Cu2S. And then barium nitride, barium, group 2 on the periodic table is a +2. Nitrogen on the periodic table is a -3 from being in group 15. So when we crisscross this time, drop those charges, barium will be a 3 and nitrogen 2, Ba3N2. So as we're writing the formulas for our ionic compounds, first decide, is it a positive and negative, a metal and a non-metal for any of them? Once you have that, to write the charges, crisscross the charge number, not the plus or minus, and then reduce or simplify if possible. Going the opposite way now, naming of an ionic compound. So the naming of an ion compound, again, we're always going to start by drawing a line. Anytime we have a question on naming or writing a formula, we're going to draw a line between the beginning element and the end. If we have a metal and a non-metal, left of the stair-step line, right of the stair-step line, we know it's an ionic compound. Our first part is we need to determine the charge of the anion. So you can use your gold packet or your periodic table to figure out the charge of that non-metal, the anion part. So determine the charge of the cation. Now that charge of the cation must balance out the total charge of the anion. Don't crisscross, or don't uncrisscross. So don't just take those numbers and move them back. It works part of the time, but it doesn't work all the time, so we don't want to get stuck in that pattern of uncrisscrossing the numbers like we just did. And then name it followed by, or with the cation followed by the anion. So our tricky ones are the ones with our transition elements. Because with those ones, we don't know what the charge is to begin with. We have to actually determine the charge from the chemical formula. So our first step, drawing a line after our first element and our second element. Chromium is a metal. It's our positive part. Oxide is our non-metal. It's our negative part. So from there, what we need to do, I'll get that to be a better positive, is that we need to first off determine the amount of anion charge. So oxygen is a -2, and we have 3 of them. So from this side, there's -6 is how much we have negative. That means we need a +6 total on this side. So we need to get to a +6 to keep this balanced. We have 2 chromiums. So if we have 2 chromiums, if each one is going to donate the same amount of charge to get to our plus 6, 6 divided by 2 means that each one needs to be a plus 3. So this is the part that we want to look into, is the plus charge must equal the minus charge. Oxygen, our anion, always has to be minus 2, so it gives us that minus 6 charge. Chromium needs to be plus 6 to balance, so 2 of chromiums, 6 divided by 2 gives us plus 3. So in the end, our formula for this, naming it chromium, plus 3, so chromium 1, 2, 3 oxide. So let's continue to look at a few more of these. First off, when it comes to naming our formulas, sorry about that, we want to draw a line between the two. We have a positive and a negative, metal and a nonmetal, so we know right away that we have an ionic compound. Our first one, sodium. Now what we can do is we can look at the periodic table. Sodium is in group 1, so it's automatically a plus 1. So we don't have to worry about finding out any of the other information Roman numeral wise. So sodium is Na. Bromine as an ion is bromide. And at this point we're finished up. Sodium bromide is the name of that chemical. Remember, it's only when we have a transition element. So our transition elements, that we need to find the Roman numerals. So an example here, iron, chloride. Iron on the periodic table is a transition element. Chlorine is our anion, so we have a plus and a minus part. So chloride is a minus 1. Chloride, there's 3 of them. We need to have a minus 3 charge over here, so our plus side needs to be a plus 3 to balance. There's 1 of them, so plus 3 divided by 1 gets us to be plus 3. So iron must be a plus 3 in this case. So when we write it out, iron 3, Cl for chlorine goes to chloride, iron 3, chloride. For the third one, C, drawing a line, we've got aluminum, that's a plus, oxygen, that's a minus, so we know it's an ionic compound. From here, aluminum, not a transition element, it's part of group 13, so it's a plus 3. Oxygen's a minus 2, so if you wanted to, you could look at aluminum is a plus 3 times 2 equals plus 6. Oxygen is a minus 2 times 3 equals minus 6, so it's already balanced. In the end, the name for it is just aluminum oxide. Again, not aluminum oxygen, aluminum oxide. The oxide tells us that we're already our ionic compound, it's already as an ion. So aluminum oxide. Lead was one of those elements that we said was going to be in the transition element category. So lead could be a plus 2 or it could be a plus 4. When we draw our line between, we have our metal and our non-metal. So lead and sulfur. So sulfur is a minus 2 charge times the 2 that we do have is a minus 4. So that means that on the other side, lead needs to be a plus 4 to balance out. We have 1 lead, so divided by 1, we end up that lead needs to be a plus 4 charge to balance the minus 4. So lead, Roman numeral 4, and then sulfur, remember, is sulfide, when it's in our ionic compound or as an ion. So the key part to remember for both of this is our transition elements. You need those Roman numerals. So remember that part as we're going forward. Remember, we're going to include lead and tin as part of those also. Besides that, we can go ahead and start in on figuring out naming and writing of our ionic compounds from using this information.